in this video we are doing Calc BC Problem Set number 10. The problems in a playlist are in the description below. Let's take a look. Above you'll find the graph of f and the definitions of the functions g and h. So g is f of x between 0 and 4, and then 1 plus k cosine of pi x from 4 to 6. H of x is going to be the integral from 0 to 2x of g of t dt. All right, so there's a lot of relationships there. We're going to use them to answer the questions. Find the value of k so that g of x is continuous at x equals 4. So continuous means the limit exists, the function exists, limit equals the value of the function. For the limit to exist, we need the limit from the left equal the limit from the right. So I'm going to start off with the limit as x approaches 4 from the left of g of x. Now we look at the definition of g of x, and if you are to the left of 4, you are supposed to just use whatever f is. So this will be the same as limit as x approaches 4 from the left of f of x. Now we just look at the graph of f, which we were provided with. If we're approaching 4 from the left, in this case, we are going to get that point, which means that we are getting 3. And then if you look, because of the definition, we are supposed to include 4 for this part of the definition. So this is also equal to just g of 4. So we know the limit from the left equals g of 4. Now we got to deal with the limit from the right. So the limit as x approaches 4 from the right of g of x. If you're approaching from the right, you're supposed to use this definition, 1 plus k cosine of pi x. So we'll have the limit as x approaches 4 from the right of 1 plus k cosine of pi x. So 1 plus whatever cosine of pi x is a continuous function, so the limit equals the value of the function. So we just sub right in 1 plus k cosine of 4 pi. The cosine of 4 pi is the same as the cosine of 2 pi, which is the same as the cosine of 0, which is 1. So this just gives us 1 plus k. And now for this to be continuous, the limit from the left has to equal the limit from the right has to equal the value of the function. So 3 has to equal 1 plus k, which means k has to equal 2. And that is the value of k that makes this thing continuous. G of x is now continuous. All right. Next up, write the equation of the line tangent to h of x at x equals 1. So we know that h of x is the integral from 0 to 2x of g of t dt. So we're going to have to find h of 1 and h prime of 1. So h of 1 will be the integral from 0 to 2 of g of t dt. And then on 0 to 2, we are supposed to just use f again. So that's the integral from 0 to 2 of f. There's just a lot of that going on here. So now we'll use the graph to find this. So the first part from 0 to 1 is a triangle, base is 1, height is 2, so 1 overall. From 1 to 2, the base is 1, the height is -1, so negative 0.5. So overall we get 1 minus 0.5, so just 0.5. We have to use the second fundamental theorem to find h prime. So that's going to be take the upper bound, so h prime, take the upper bound, which is 2x, and sub it in. So we get g of 2x times the derivative of 2x, so times 2, which means that h prime of 1 will be g of 2 times 2. And then g of 2, we know that between 0 and 4, we're supposed to use f, so g of 2 is going to be f of 2, so 2f of 2. F of 2, if we look at it, is going to be -1, so that's from the graph. And so we know that h prime of 1 is -2. And then we'll write the tangent line in point slope form. Y minus 1/2 is -2 quantity x minus 1. Okay. Find and classify the critical points of h of x. This problem is terrible. I didn't realize it when I was writing it, but it's a pretty annoying problem. So first let's think, like, what are we dealing with in terms of domain for h of x? So h of x is the integral from 0 to 2x of g of t dt. But g is only defined from 0 to 6, right? So if we, instead of say g of x, say g of t, t would have to be between 0 and 6. And then when we do h of x, it's the integral from 0 to 2x. But those are t values, right? Because it's g of t dt. So t equals 0 to t equals 2x. We need to make sure that 2x is in between 0 and 6, or we can't do the problem. So because of this 2x and this domain, we need to make sure that 2x is in between 0 and 6. That's going to be crucial. Which means that the only x values that we're allowed to have by definition for this function are between 0 and 3. Keep that in mind. All right. Derivative. This is the second fundamental theorem again, so it's going to be 2g of 2x. We need to figure out when the derivative is 0 or undefined. The derivative is never undefined because we went out of our way to make sure that g of x was continuous on the interval from 0 to 6 in part A, I think. So we know the derivative is never undefined. We just need to figure out when it's 0, and if h prime is equal to 0, that just means that g of 2x is equal to 0, basically. Okay, now let's look at this thing. For when we're dealing with the part that's just f, we know that f is 0 by looking at 1 and 3, but those are 2x. So 2x is equal to 1 or 2x is equal to 3. So if we have 2x is equal to 1, then x must be 1/2. If we have 2x is equal to 3, then we have x is equal to 3/2. Those are two critical points. The derivative is definitely 0 there. Okay, now what we need to do, so let's box those. We need to deal with the part that has g involved, right? So if you look at it as g of t is 1 plus, we know that k is 2, 1 plus 2 cosine of pi t. Now we're doing g of 2x, so that's going to become 1 plus 2 cosine of 2 pi x, right? Because it's g of t is 1 plus 2 cosine of pi t, g of 2x is 1 plus 2 cosine of 2 pi x. All right, we have to solve this, but the only place this is valid is between, so t is between 4 and 6, which means that 2x is between 4 and 6, which means x is between 2 and 3. We're only allowed to get values between 2 and 3. Going to be relevant, but first let's solve this. This is like a pre-calc type problem, math analysis if you took my class. We have cosine is -1/2. We think, where does cosine equal -1/2? That's at 2 pi over 3 and 4 pi over 3. So I'm going to start with that. So 2 pi x would be 2 pi over 3 plus 2 pi n, right? Because every time you go around the circle. Or 2 pi x is 4 pi over 3 plus 2 pi n. And then in general, n has to be an integer. So if n is an integer, let's just divide through by 2 pi, apparently is what I'm doing here. So x is 1/3 plus n, or x is 2/3 plus n. We know that n is an integer. I knew I was going to write that eventually. I didn't know when. Okay, so if n has to be an integer, and we have this domain restriction. So remember, the t value is between 4 and 6, which means that the x value is between 2 and 3. So when we solve this thing, we're only allowed to solve between 2 and 3. That means that when I start looking at these things, I basically need to make n equal 2. Because if n is 0 or 1, we're not in the interval. If n is 3 or more, we're not in the interval. The only n value that works is 2. So if I let n equal 2, I get x is 7/3 or x is 8/3. So those are two critical points. So it turns out there are 4 critical points. This is like a pretty challenging problem, it turns out. This is definitely an AB level problem, but like, oof. All right, we got to classify these things. Looking just at the graph of f, right? I know that this is the graph of f, not the graph of f of 2x, which it should really be, but f of 2x would just be shrunk by a horizontal factor of 2. So like the pluses and minuses, the positives and negatives don't change, right? The location changes. So we can look at this and say, like, since this graph changes at 1, h prime changes at 1/2, but at 1/2 we're changing positive to negative, so that's going to be a relative maximum. At 3/2 we're changing from negative to positive, so that's going to be a minimum. Just pop that up there. Now what do we do with 1 plus 2 cosine of 2 pi x? What I'm going to do is I'm just going to kind of like sketch over everything. This is going to look ugly. I'm just going to sketch over everything, the graph of 1 plus 2 cosine of pi x. So I'm just going to add this. This is a bad idea. Well, it's not a bad idea. Now the actual derivative, remember, is going to be twice as tall because it's 2g of 2x. So it's twice as tall, and it's shrunk by a factor of 2, or like by its multiple. Everything is half as far, right? So really we're shrunk between 0 and 3 instead of 0 to 6. But the changing from positive to negative, negative to positive doesn't factor in here. Maybe when I'm editing this, if I edit this video, I'll put in like a graph of the actual derivative, hopefully. All right. We know that we are changing from positive to negative at that first critical point and negative to positive at the second critical point. That's the key. So I'm going to say h prime changes positive to negative at the first critical point, which is 7/3. So h of x has a relative maximum there, and then changes from negative to positive at 8/3. So we have a relative minimum there. This is a challenging problem. Of all the like Calc A B level problems that I've written in a while, this one's way harder than I thought it would be. All right, let's take a look at the next one. Find the volume of the solid form when g of x is rotated about the x-axis between 4 and 6. Hopefully you got the value of k right, because we just keep using it over and over. All right, so this one is straightforward, just volume of revolution. So we know g of x is 1 plus 2 cosine of pi x. So we're just going to do pi, the integral from 0 to 4, and then the radius, which is g of x squared dx. It's a calculator problem. So I'm going to approximate this, so I'm saying approximately. According to College Board, if you round to 3 decimal places, it's the exact answer. I don't like that. If you're rounding, use approximate. The calculator screen, here you go. I got 18.8496, my least favorite type of rounding, but I'm going to say it's 18.850. That's it. So it ends on a much better part. All right, let's take a look at the next question. Evaluate the integral of x plus 2 squared cosine of 3x dx. This immediately to me looks like integration by parts. I'm going to let u be the polynomial thing, so I'm not going to expand that. I'm just going to leave it as is. And then dv will be the trig stuff or whatever's left. So cosine of 3x dx. I'm going to use a table on this because it's repeated. So uv and then the sine. So for u, you're putting u in there and taking derivatives. So it'll be x plus 2 squared, and then 2 quantity x plus 2, and then just 2. And then it would go to 0, so like 0 times anything is 0, so we don't go that far. For the v column, you are always putting v and then integrating. So you start with dv. You have to figure out v, which in this case would be 1/3 sine of 3x. And now we're going to keep integrating. So you don't put dv in the table. You put v in the table and then integrate from there. So negative 1/9 cosine of 3x, and then negative 1/27 sine of 3x. And then for the sine column, it's always just minus, plus, minus, plus. It just keeps alternating minus and plus, starting at minus. We don't need one in that last spot because we're not going to keep going from there. Okay, so I'm going to call this I and say that I is. What you do is you multiply u and v, and then you just put the sign, right? So that's like your first term. So it's u times v minus. And now you're going to do u times v plus. And then you're going to do u times v, like this, and then plus c at the end. Now what happens is you don't always get a pattern of minus, plus in your final answer, because sometimes v has minuses, sometimes u has minuses, whatever, you just do all the math correctly. I'm going to simplify this but not make you watch, so I get 1/3 quantity x plus 2 squared sine of 3x plus 2/9 quantity x plus 2 cosine of 3x minus 2/27 sine of 3x plus c. If you check that on a calculator, your calculator will like combine the sine of 3x terms. That's okay for a calculator. I think a human would leave their answer like this any day. All right, so let's take a look at the last question. It's a long problem set. Evaluate the derivative of 5 to the sine of x. All right, so a to the u, the derivative is a to the u, natural log of a, du dx. So we're going to have 5 to the sine of x, that's a to the u. The derivative, or rather, natural log of 5. You just want to like get that natural log in there immediately so that you don't forget it. And then times the derivative of sine, which is cosine. I'm just going to leave that. I think it looks fine. I mean, I think like, honestly, I don't know. I guess, which would I rather come for? It doesn't matter. All right, so I'm going to leave that. The derivative of arc sine of e to the x squared, the derivative of arc sine of u is 1 over the square root of 1 minus u squared du dx. So this will be 1 over the square root of 1 minus u squared, so e to the x squared squared, and then times the derivative of e to the x squared, which is e to the x squared times the derivative of x squared, 2x. Okay. I'm just going to rewrite, like there's nothing special, but 2x e to the x squared over the square root of 1 minus e to the 2x squared. All right, that's the little problem set. I hope this was helpful, and good luck.